Good afternoon, my fellow scientists. It is Monday, July 31st, 2017. I want to talk a little more about the iron battery. First question from the comments. Thank you very much for your comments. I very much appreciate them. Question is, why not use a nickel electrode? Well, nickel's one, significantly more expensive than iron, and two, if your nickel electrode becomes contaminated with iron, or your iron electrode gets contaminated with nickel, your battery has now lost capacity. And also nickel salts tend to be fairly toxic. So some fairly good reasons to stick with an all-iron system. Most important for me in this case is that if I'm trying to build an open source, low-cost battery, going with one low-cost material keeps everything simple, safe, and easy to assemble. For this particular battery, the way we assembled it was to take iron wire on one side in the form of steel wool and an iron 3 EDTA solution on the other side with some conductive carbon to allow charge transfer. And then we put all that in a plastic bag and it cycles beautifully. So check this out. This is 100 cycles up and down. The state of charge is clearly drifting somewhat, so I can't say for sure what the Coulombic efficiency is, but we can say that it's a fairly robust cell, able to be cycled many, many times, and although its state of charge may be changing a little bit, it's not changing so much that the voltage drifts a huge amount. So we need to do some more rigorous testing to determine exactly what the full capacity of the battery is, and then charge and discharge it to a full 100%, then we can assess the Coulombic efficiency and the actual number of cycles before it falls apart. For the time being though, if you zoom on one cycle, you can see that the charging voltage is about 30% higher than the discharging voltage. And since this is a constant current charge and a constant current discharge, and it's the same current, we can estimate that the energy efficiency in and out is going to be something like 60%. So all told, first characterization of the iron battery implies a decent self-discharge rate, a pretty good robust resistance to damage during charging and discharging. Still a lot of work to be done to fully characterize the battery. So stay tuned tomorrow for more science, chemistry, and the limits of the DIY iron cell here in the Allen Lab.